My name is Ajey Gore. Um, I'm a developer. 10 years back, I used to contribute to OpenOffice. I'm a system administrator as well. So I headed ThoughtWorks global IT operations for almost 10 years. And last 1 and 2 years, I have been head of technology for ThoughtWorks. And since last 6, 8 months or a year, I have been working on internal projects and products. And my recent encounter was developing an internal DevCloud, which is a development environment for ThoughtWorks. And that's where I'm a DevOps guy as well. So this talk is more like a discussion. Can I have a awesome? That's okay. That's okay. You would have played nice music or dance. Anyway, can I have mobile phones on mute, please? If and no more movies playing on the record. So this is more like a discussion. It's not really a talk where I'm gonna come and tell you a lot of good top 5 tips of creating a private cloud or something like that. It's more like what I have learned in last year and want to bounce off those ideas to you and figure out what else is going to happen. So talk will end pretty soon. It's not going to take more 45 minutes, and I would expect a lot of questions. Do we have Ranjeev here? Yeah. So we have Ranjeev, we have Nikhil, and we have Bhavin Javia. Those are the guys who have shown interest, so they are also there. And Ranjeev and Nikhil have worked with me on the project. So if there are more questions, they will also participate and answer those questions if possible. So let's talk about talk itself. So what happens in today's world? Lot of enterprises or your companies need lot of things on demand, and sometimes they can't get those. The reason is that you don't have GitHub in house, you don't have AWS in house, or you don't have S3 in house. Since you don't have those things in house, you have a big IT department next to you, and you request a VM takes 5 days, or you request access to repository. You get a repository and you want to add somebody to that repository, takes another 5 days. So what happens at ThoughtWorks, we are one of the niche consultancy company, and we thought, what if we create something like that, which gives the enterprise development environment, but on demand. And that's where you go and request a Git repo, like GitHub, and you get it, add your employees or colleagues to it, and you don't have to go to IT. Same way with your VMs environments, and basically creating a private cloud. We can do that, but it required a lot of instrumentation. And we started our journey with OpenStack, then we went to Eucalyptus, then we went to containers, and all that stuff. This talk is all about that journey. And at one point of time, since I am an administrator and I am a developer as well, and my colleagues are administrator and developer, we thought we will use Ruby everywhere. And so Ruby for development and Ruby for operations. If we do that, one of the things is that IT administrators and my developers speak same language. So we create a one big team instead of creating 2 silos, and we bridge a lot of gap around the communication itself, and they all sit on one table. Also, this helped us in one more thing, is that everyone knows what they are doing and everyone can understand what the others are doing. So I wouldn't spend a lot of time on why Ruby. It's a nice language, huge community support. Charles Letter today morning said that we should do polyglot programming, but we actually chose Ruby to do everything. We did not write applications which will scale. We did not write applications which required Scala or Erlang or something like that. So we could do away with Ruby for a lot of stuff. And we had multiple implementation. We used JRuby and MRI both. And later on we shifted to MRI, but our application still runs on, a lot of applications still runs on JRuby. I wouldn't talk about development because most of you do development. You know what Rails is, you know what Sinatra is, you know how to do development in Ruby. Also, I will not talk about build and testing because you all know how to run unit tests, you all know how to write RSpecs and all stuff. But what I'm going to talk about is what I have been doing for ages, that is starting with provisioning. So if you look at any project, once you start, once you start on a project, what you need? You need a basic operating system. And how do you provision it on demand? Second thing what you need is, once you are done with provisioning, you go and take next steps. So let's talk about provisioning a little bit. So how many of you know fog? Good. So this is what fog does. This AWS example, you can replace this AWS example with lot of other cloud providers. You can say Rackspace or you can say something else. The reason we use fog because we can create abstraction on top of what we are doing. So we can replace our cloud implementation with something else. So today we are living in Eucalyptus or OpenStack and we want to move everything out to AWS for our clients. We can do that. And that's why we chose this abstraction right on top of it. So actually if you look at fog and if you look at the parameters, they don't change significantly across the cloud providers. And that's where you actually do this, and this not only defines the whole thing into Ruby, but also it's kind of a DSL for you as well. If we look at deployment, so what do you use for deployment? Chef for deployment. Ruby guys, before Chef. Capistrano. Capistrano is pretty nice choice, and I had to fight a few people to why we shouldn't use Capistrano, but here is how a small Capistrano code looks like, and it's very simple. Like I have two roles, app and web, and I want to do deploy, and I want to do deploy only on app, and I just go and run deploy command on the app servers, and Capistrano will do it for me. But if we just do this, how do we treat our applications as first-class Linux citizens? That is one of the keys. Most of the applications what we write, they tend to keep configuration and the application logic at the same place. But if you look at most of the Linux applications, they don't tend to keep a configuration and binaries at the same place. Simplest example is HTTPD server. The configuration lives inside etc HTTPD in CentOS or Fedora flavors, in Apache 2 in Ubuntu flavors, but the binaries live somewhere else. The main difference between our written applications and system provider applications are because they treat the configuration as operating system data. And as long as you start doing that, then if you upgrade your application multiple times, you don't have to worry about configuration files. Like RPMs will write the RPM new file over there for the configuration, and your application will be guaranteed to still work. So that's where you actually start using something like configuration management. And that configuration management tools, I'm going to talk about Chef over here a little bit, but those configuration management tools gives you that abstraction of treating your configuration files as data for the operating system. So your configuration should live inside somewhere which is not touchable by your application binaries or scripts. And that way, if you overwrite your binaries multiple times, it does not, you don't fear that you will be deleting your old configuration management files, or you will deleting the specific keys or SSH keys, private keys, a lot of stuff. You don't want to check in those stuff. But a lot of time, if you use old style, or if you use old style is kind of controversial thing, people still use Capistrano. But if you use something like zip, tar, and untar and deploy your application, you are into fear of deleting your files, or you actually untar the whole thing and copy the files from somewhere else to your own local directory. Instead, if you treat this and do something like this, which actually makes sure every time this is reapplied, you are sure that your configuration is going to work. So what is this doing? So I'm actually, this is a simple HTTPD definition on Chef. What it says that before executing me, execute yum-y update security. Put all the security updates every time you find a new package. Then install the package HTTPD, and then I define a service. So a package has a service as well. So I say this is the package, this is HTTPD package. I define this service, this package provides this service, which is HTTPD service, and how do I actually configure this service? What does the service needs to understand? So I say, look at conf.d and mysite.conf, which is my file, and every time you find a change in this file, notify the reload to Apache. So suppose I have multiple sites hosted as a virtual host inside my Apache host, I can create one cookbook file for each of the configurations, and every time I change it once, it is going to change everywhere else. So first thing, the provisioning, if you remember, gave you the ability to create self-serving virtual machines on demand. Second thing, which is Puppet, Chef, gave you the reconfiguring it, making it idempotent across the packages multiple times. So how do I bring these two together? And how does Ruby help me over there? So if I do something like this, which says knife EC2 server create, and my run script and roles are this, what it's going to do, it's going to go create a box on EC2, apply a run list of web server, and then pull up those cookbooks which are applicable to it and run that. So basically I get a web server on demand whenever I want. And it seems tedious. So one of my colleagues long back used to ask, if I have only one application server, why do I have to automate it? There is no need to automate it. There is no need to do something around it, which makes me write a script which takes 3 hours. But if you look at today's world, we deploy every week, or some people deploy every day. That means you are installing almost every day. That means you are installing 30 times a day, 30 times a month. If that is the case, then you might as well automate it as much as possible. And once you automate this, there are a lot of other stuff where Ruby can help you. So what happens when a complex system deployment takes place? How do you orchestrate that? And do you need orchestration? How many of you believe that you need a infrastructure orchestration on demand? So there's a basic need that today's web world, today's web 2.0 or today's world is a lot, and it requires multiple servers across multiple time zones and across multiple EC2 zones to actually put them all together. And if you put them all together, how would you put them all together? There has to be a sequence. Simple case, if you take a Rails application and if you have done database change which has dropped the column, how would you deploy it? You have to drop the column first, then most probably you have to deploy the Rails application. But what if old instance is still running? It will break. So that you cannot always do DB migration before or after, before the application deployment. And if that is the case, then there has to be some workflow to be managed across the instances. Also, if you have multiple 5 or 6 Rails instances, will all of them run DB migration? And what is the sequence will be that? And if you look at these questions get really complex. And at that point of time, you need some orchestration. And there are a lot of ways to do it. But one of the good ways when a new host comes up, how do you deal with that new host? Like once I have a new host, what do I do with this? There are other services which are dependent on that host. Like as soon as I bring a new host, I need automated monitoring for it. And once I have monitoring for it, I also want to make sure I have backup schedule listed for it. Also, I want to make sure that it gets entered into proxy. Let me give you a simple Rails application scenario. So you have 5 Rails servers which are running, or 5 Rails instances. You brought a new instance up. What all changes you need to do? You need to configure its database. You need to add it into a proxy, Ajey proxy or load balancer, wherever it is. You need to make sure that its monitoring is started. But what if you remove that instance? Then somebody has to go and remove it from the proxy. Somebody has to go and remove it from the monitoring as well. Because if they don't do that, then most probably some wrong or false alerts will come. So once you build the whole, we call it build infrastructure fixtures. So once you build the whole thing up, ground up, then most probably what you need to do, you need to notify all these services across the place to make sure these entries are done. And if that is the case, then how would you actually trigger those events? Because you can't, somebody cannot sit and do it sequentially. So somebody has to understand. So how many of you understand this? Anyone else? Okay. So let me tell you, let's for a minute forget the MCO command. Tell you this, what it is doing. What I'm saying is execute chef on the servers which have a fact or which tell me that they are monitor instances. Then execute the chef on all the servers which tell me that they are app servers. Then execute backup script on all servers which tell me they are DB, and so on and so forth. So what I'm doing, I brought the new host up. As soon as I brought the new host up, I dropped a message. So I'm actually using a command line, but what you can do, this is M collective. So what you can do, you can drop a message saying, okay, now monitor server, please go and run yourself. So what monitor server is going to do, so we use NagOS and then we use Sensu behind the scenes. So what it's going to do, it's going to go and ask chef, give me all the servers you have, and it will find one new server and reconfigure the whole server and add that into Sensu, basically. Second one is saying, and my new host is app host. So app host knows what it needs to do to configure itself, where to find the database configuration, where to find other related configuration, and how do I actually get my all source code. It knows all this stuff. It will run that, and once it runs that, then I'll go and talk to backup server saying, okay, DB, please go and back up yourself, because I'm gonna next command is I'm gonna deploy this app server. And after that, I'm gonna say, once the app server is deployed, add it to load balancer. Instead of, so this is the first way of doing it. Second way of you doing it is when you do a create instance itself, after that you can fire up these 5 messages. And you will be sure most of the time that your new host has been properly configured and added into system. So we talked about development, build and testing, provisioning. After that we talked about orchestration. Once you have the whole system up, then how Ruby can leverage you to monitor the whole thing? Because you need to know what is up. You need to know statistics, right? You need to know a lot of statistics, because you need to make certain decisions based on your statistics. So if you keep monitoring your concurrent connections, or you can keep monitoring your concurrent connections to a specific instance of the Rails or a specific instance of web server, and you know that my web server can deal with only 8 or 10 concurrent instances, you can put a business intelligence over there saying, as soon as any of the servers reach 80% of the capacity, fire up one more server. And once you fire up one more server, the same thing will go away. And then you can fire up the proxies, monitors, and all the stuff. But on the other hand, you can always say that if my 2 servers are sitting idle, remove them also. Because since you are talking about virtual machines and containers, you are not talking about physical hosts, you can actually shut down or remove or suspend the servers as well. But once you suspend a server or suspend a container, you might want to reverse everything what you have done in the past. You might want to remove it from proxy, you might want to remove it from monitoring as well. So this is JSON, but read by a Ruby tool. So this is how you define very, very simple web app, which says, my name is webapp01.local. I intentionally use local because one of the mistakes lot of developers do, they give fully qualified names for internal instances. And a lot of time what happens, somehow by mistake, if that instance gets publicly open, somebody can hit that instance. But if you give only private DNS entries, even though if it gets open outside, even though names gets leaked outside, people still can't reach it. That is one of the things which we always do. So we have this web app.local, we have address is 10.0.0.1 and subscriptions are web. So as soon as I say subscription, that means I have defined those subscriptions somewhere. For web, it's port 80 by default. And then I can create more subscription as much as I want. So we came till this point till monitoring. But what happens if your system goes down? What do you do? What do you do if your Rails application goes down? A lot of times you either use Monit, or if you don't use Monit, you just go and kill the Rails application and start it again. Or it hangs, or if it is like stops responding, or if process dies, we just start it, nothing else. Lot of time, 90% of time we do it manually. But what if we put something called supervising? That's what we do, right? Manually we do, first thing we do, service HTTPD restart if it's not working. If PID file is done, or service HTTPD start, or bind start, or whatever we do. That is called supervising. And Monit has been playing very nice role into that for a long time. But you can define something like this. You can say bluepill.application HTTPD do app, and then you can go define the whole application in DSL. And tell it that the PID file is this, and the start command is this. If you find this application doesn't exist, so what it does, it goes to PID file, looks at PID, it finds the PID doesn't exist, it will remove the PID file and start it again. And you can generate this configuration automatically using Chef. So as soon as I say that my host is a web server host, then if you have Bluepill cookbook into Chef, the Bluepill cookbook will go and write this. Or you can also say this role subscribes to Bluepill supervising, and then Bluepill will figure out what all roles this has, and does it have a Bluepill configuration for all those roles, and go write those things. So if you look at this whole scenario, give me 1 minute, I'll get back to you. Let me finish this, and because I'm gonna finish very quick. So let me finish this, and then I'll talk about that. So basically, the journey we started was provisioning, to deployment, to orchestration, to monitoring, and then supervising. I did not touch development and testing yet because there is that triggers the whole thing, that triggers the whole cycle, right? So now let's take an example of your complex or your small web application, which has something like this. So a user comes, says, I want a Gitolite box, and our application allows you to sign up on a private web server and say, I want a Gitolite box. What happens after that? The web application drops a message saying, we want a Gitolite box, and we make an entry in the Chef data bags saying we need a Gitolite box. One of the OpenVZ, we use OpenVZ and KVM a lot. One of the OpenVZ or KVM containers boxes will get up and see, do I have, so there is new host come in, but is it assigned to me or not? And what we do is in Chef, we look at the capacity of each boxes and say, okay, this box can create one more Gitolite box. That box gets up and creates a box, but it created the only box. It doesn't have anything else and doesn't know anything else. Then what it does, inside the Gitolite box says, go configure yourself. The Gitolite box also has a project ID, and it knows where to pick up the SSH key and how to configure itself. It configures itself and says, I am up. Now, as soon as I say I am up, then 2 or 3 services will wake up and say, okay, monitoring will put that into the monitoring system, backup will put that into backup system, and statistics will put into a statistics system, because we need centralized logs also. The log should go to central place where we can analyze them. So once those 3 things are done, then DNS will make an entry, and that entry will get published to the user saying, here is what it is, your gitolite.project.local is available, please use it. So that's how the whole provisioning we did, and that's where we use Ruby. And that's why I call it Ruby's ubiquitous. You can use it almost everywhere, wherever you want. And it is not that we could not use some other language, but it is more like we took it as a challenge, we took it as a fun, and let's see if everything can be done using Ruby or not. And that's where I end my talk, and these are the references. Now, Tejas, your question.
What is the difference between, why would I specify a start command when I have something like the service thing from before?
In the blue pill?
Yeah, so somewhere earlier on, yes. So you have this which defines a process in the start command, and somewhere earlier you had a service HTTP D or something. I was just
Okay,
wondering, are they the
yeah.
same thing or?
So, this command will make sure if HTTPD dies, it will start it. So, it will keep monitoring it, and it will start it when the HTTPD dies. Also, this command is mostly, since blue pill is very much, blue pill does not have operating system abstraction. That's why I need to give exact command. So it can be service HTTP restart on the CentOS, but it won't be service HTTP restart on a Ubuntu system. But this will work across the place. On the other hand, if you look at my services thing, what I'm saying, I did not tell it what operating system it is. Because what Chef does service abstraction for you. So if you say install package HTTPD, on CentOS it will say yum-y install package HTTPD. But it is intelligent enough to figure out, do sudo apt-get Apache 2 on Ubuntu systems. So it does all that stuff. And this configuration just defines the service and its configuration. This configuration does not define how to monitor the service and how to restart it if the service dies. Any more questions?
Hello. Yeah. So given that Puppet is also sort of a Ruby thing, have you had experiences with it? And in comparison with Chef, how does it come?
I knew that question is going to come. Okay. We were the first one to use Puppet. I used Puppet in like 2006 starting. And what is it? Yeah. And Puppet was way before Chef, right? One of the things which Puppet did not provide at that point of time when we moved to Chef, it does now. So now the choice is a little bit awkward, but yeah, it's still we'll say Chef experience has been better compared to Puppet. But let me tell you what it is, what is the basic difference and why did we move to Chef. So Puppet does a compilation of client definition at the client side, while Chef does the compilation of client definition at server side. So if I want to know how many web servers I have in my system, with Puppet, in 2009, we couldn't do that. Now you can do that using exported resources. But in 2009, you could not do that. You could not figure out how many web servers I have in my ecosystem or how many DB servers I have in my ecosystem. With mcollective and Puppet, now you can do that. With Chef, it comes automatically. Also, the power of Chef is that I can query a lot of stuff on Chef, saying, give me all the nodes which apply these roles, or give me all the nodes which have been run successfully in last 1 hour. While Chef, Puppet cannot do that. Now it can do that again with mcollective and Puppet plugins together. So that's where we moved to Chef. And one bigger advantage was that Puppet DSL is kind of seems like system administrator friendly in the beginning, because you are used to having those transactional things. Like I have been system administrator, so I like that. Like I have transactions right there. But complex IT infrastructure is not transaction anymore. It's not. It's complete rollback also is required, which is very impossible to do it with Puppet at that point of time. Now you can do that as well. Third thing was the DSL made more sense in Chef compared to DSL what Puppet provided. So in the Chef world, we can, should I go into that? Okay. In the Chef world, I can actually in the Chef world, I can actually look at this. If you look what all things I'm querying over here, I'm actually setting up subtunnels. But if you look over here, I'm actually making some decisions around what it should look like, and I'm creating templates and iterating through them. You can't really do this in Puppet. You can't really query how many nodes I have and create those many configurations per node in the Puppet world. So that's where we actually move towards Chef compared to Puppet. Does that answer your question?
Pretty much does, yeah.
Okay. Okay. Yes, Dhananjay.
Yeah. Just wanted to know, when you talked about orchestration, was the tooling, did it give you the support for either whenever you run into errors, stopping and resuming from that point, or rolling back whatever it had done till then, so that you can start from scratch? So basically what I'm saying is, did this tooling help you completely in terms of whenever an error happened, and it happened in the orchestration workflow, which meant it left you somewhere halfway, did it allow you to kind of appropriately recover from that?
It did allow us to detect the errors very quickly, because if you look at the monitoring, we could also monitor whether nodes have converged or not in last 10 minutes or not. So when I triggered an event which triggered 3 more events, I expect some convergence of the nodes across the chain. And what we did, we also monitored whether node converged or not, and also monitored whether our Nagai system or sensor system actually picked it up or not. So it also helped us little bit around rolling it back, because there are some network connection issues or whatever it is. Second thing, rolling it back was only and only required when we had a deployment. During provisioning, rolling back was not necessary, because we could just run the commands again and it would converge next time if there are some other related errors. Is that okay? Yeah. Yeah, so the orchestration helps you in 2 ways. One way is that we don't have to poll every 5 minutes what's happening. So what happens is, if you create something and you either have to poll or you have to run a cron job. So the basic pattern is that I created something, put it into queue, and the cron job will wake up every 5 minutes and do it. But when we needed things trigger fast and on demand, that's where orchestration helps us a lot. Orchestration did not help us in troubleshooting errors immediately, but it did help us to highlight the issue immediately. So we have to do some manual intervention at some point of time.
Yeah.
How did you actually handle application deployment? We were talking about Capistrano. Personally, I hate Capistrano. I switched to Fabric.
Yeah.
So
me and Nikhil did a patterns of Ruby on Rails deployment like 6 months back in DevOps days. There are a lot of ways you can do it. There's no better way on top of other. It depends on your comfort zone. The easiest one is that you do a tar of your application, put it on web server, and notify the application server that new application has arrived. And it will wake up and download the tar and deploy it. Second easiest way is you do RPM package. So first way, the tar does not give you modular granularity of what application version you are deploying and how do you deal with it. It just doesn't have any application specific metadata. It just has application metadata, right? On the other hand, if you do RPM, that means you are increasing versions, and you publish the RPM, and you have your custom yum repo, and Chef will automatically, next time it will run, all the app servers will run, and Chef will make sure it installs the latest package. So you can do that as well, and gives you the application transactions on top of it. The third way, which is very crude way, is you do a tag based Git.
okay.
So yeah, so there are multiple ways. It depends on how you want to do it. What we wanted to do, we wanted to make sure that application deployment is inside configuration management. So that's where we used Chef to deploy those applications rather than doing Capistrano to deploy the applications.
So in Chef, instead of using directly the system packages, or did you compile RPM packages?
We compile the RPM and then define the cookbooks, right?
But the problem that I ran into with compiling RPM packages for something like Rails applications is the dependency hell.
So we had JRuby.
Okay, but what about gem sets?
Because you check the gem sets in. So you don't have to worry about, like, JRuby takes that pain out for compiling native gems out of you almost 90% of the time.
Okay, the only well, for me that managing all those RPM dependencies became a big problem. So what I did and end up doing was I started using bundler. As it is now that I'm trying to use RVM on the server, what I find easier to do is use bundler, have Fabric connect to a staging server, compile the application there, compile the bundler, the gem set over there, and then just rsync the application to the server, switch a symlink, and your
You can
version
do
is
that.
live.
So one of the things is with our latest project in Delhi, what we did, we ended up actually making RPM for every gem we used. And that's how if you know Arbel Frame OS repo, the way they install Chef server, they have every gem as RPM available. So you can do that as well.
I tried that, it just got out of hand.
It is easy. If there is a, now I'm
Gem to RPM something.
gem, no, it's FPM. If there's something like FPM or FAR, which
Acha.
actually can do that for you.
Okay, I'll check that out.
Yeah.
Thanks.
Yes, Michael.
How do you you're using Chef, so obviously you're using a lot of cookbooks and a lot of recipes, right? How are you tracking version control with different recipes? Because do you check your whole cookbook folder in with?
No. So that
Do
is
you use Git submodules, or what are you using for your?
So there are 2-3 ways to do it. One, in Chef, you don't check in anything to Chef server. You upload stuff. So one thing is that you can actually implement something called Chef lint, and Nikhil actually implements something called conformity monkey, and you can implement a lot of those monkeys, which actually make sure that if your version of your file has increased, then metadata on the Chef cookbook should increase, and then you run a CI on top of it and it should fail. So basically, because Chef repository and Chef cookbooks, the two are separate entities, and if you have to bring them together, you have to implement some CI or lint tool on your own, so that they are consistent.
Yeah, no, I understand that, but like we've got, I'm just wondering how you solve this problem. We solve it our way, but if you've got a cookbook and you're pulling in somebody's recipe for Apache server, and that's a very well maintained recipe, and you want to keep that as an external dependency, have you got any particular way of solving that, or are you just forking that into your repository and taking a copy of it and then manually tracking with it?
No, we actually used the last stable version, forked it, kept it. If we required a new version, we got it again, saw it working or not. But basically, we have not ran into that issue till now.
Fine.
Another thing was we are CentOS based. We did everything based on CentOS. Chef cookbooks are CentOS or Red Hat, and Chef cookbooks, most of them are Ubuntu focused. And so we ended up writing a lot of stuff on our own, or ended up porting a lot of stuff for CentOS for our own. So we did not run into that situation yet.
Okay, last question. On.
This is something relating to probably Chef or Puppet. So, say you wanna like install like say 10 packages and one of which fails. So apt-get tries to reinstall the failed package every time, right? So how do you usually manage that kind of situation when you don't want the next 9 packages to try reinstalling the failed package because you know that it's going to fail again?
No, you need to fix it, because you will come to know on Chef that node did not converge, so you need to fix it anyway.
Correct. You need to fix it, but the time you're running the I'm not very conversant with Chef, but when running the configuration, what happens is the rest of the 9 packages end up trying the same thing again, and it takes like 4x times the usual time it takes.
I still did not get your question.
It's Mhm. Correct. Right, but that's more of an apt-gets thing or aptitudes thing more than a Chef's thing.
No, it's the thing is this package provider, right? If you
No. So what usually happens is when apt-get knows that your build tree is faulty and knows that something has failed in post installation, it tries to reinstall those packages or reconfigure them. Chef or Puppet for that matter have no control over it.
Yeah, because Chef and Puppet should not do that. In first place, they should not do that because somebody else, much more mature, who understands system, operating system, is doing it. So you should rather fix that instead of try to take that responsibility one level up and fix it at one level up. Then the problem is then you will end up creating so much of if else code or so much of ignorance code in your cookbooks, which will actually create more confusion than let it be handled at operating system level itself.
Okay, I think the problem is a bit more deeper. We can catch up offline.
Okay, yeah,
Yes.
let's do that. That's it. Thank you guys. Thanks a lot.